have a reaction of nitrogen monoxide, a molecule, combining with chlorine molecules, and they're going to make something called nitrosyl chloride, NOCl. So I want to make a rate law for this. So when I do a rate law, I have a constant. I have a concentration of my reactants to some order. Let's use X. And I have some chlorine to some order. Let's use Y. My products I don't need to include in the rate law for this one. Now, when I look at my experiments, I'm given 3 experiments, and I want to use 2 experiments where one reactant is constant and the other changes. Well, if I look at my first 2 experiments, if I look at experiment 2 and compare that to experiment 1, I see my chlorine changes and my nitrogen monoxide does not. So let's start with that. So the rate of these 2, I'm given the rates. I'm told that this is 0.36 and this is 0.18. And the rate law then is my constant times my concentration of NO and my concentration of Cl2. And that's experiment number 2. Make sure you keep the right experiment in the right place. And then experiment number 1, my given concentration and my chlorine well, I can simplify this. Those cancel, and if I divide that, and over here if I divide this, well, 2 to what power equals 2? Well, of course, that's 1. So this is a first order reaction as it applies to chlorine. Let's do the same thing for NO. So I need something, well, where NO changes and Cl2 stays the same. And so let's see, if I have rate 3 and rate 2, let's do a ratio for those. From rate 3 to rate 2, my NO doubles, but my Cl stays the same. So my rate for the third experiment is 1.45, and my rate for the second is 0.36. And that's equal again to the rate constant times the concentration, and this is experiment 3. And experiment 2 on the bottom. And let's simplify. These 2 things cancel out. 2 divided by that is 2. And if I divide this, I get 4. So 2 to what power is 4? Well, of course, it's 2. And so my reaction is to the second order for NO. And so for my answer for A says write the rate law. This would be the rate law. Second order regards to NO, first order to Cl2. If I wanted to have the total order, I would add those together. This would be third order in totality. Then the next part, part B, says, or asks for K. And so I can solve K, I can figure out K, so let's do B over here. I think we have room. So the rates, well, I can find values for any of my three experiments, or I can use values for any three of my experiments. So well, I like to use number 1, why not? So for experiment number 1, I am given a rate of 0.18. It's important on these ones to write the units out. My concentration, it's important to write the right units out too. This one is actually per minutes, liters minutes. All right, and in my concentration, I'm going to do them in the same order, of course. NO is 0.10, and it's to the second order. And this is in molarity, moles per liters. And it is to the second order. And then my Cl2 for my first experiment was recorded as this. All right, so I need to square everything in here. So I'm going to go 0.10 squared. And I need to square the moles and the liters. And over here, this is to the first order, so I don't have to do that. And if I multiply these two things, now I have moles squared and moles, so when I have exponents like that, I add them. And same on the bottom. And all of this is, the left side just stays the same. I lost my K. And now I want to get K by itself, of course, so in order to do that, I'm going to multiply by this reciprocal, which would be liters cubed, moles cubed, and of course, if I do it to the right side, I have to do it to the left side. That cancels. That cancels. And so over here, I have one of my liters can cancel. So I'll take one from the bottom and one from the top, leaving me with 2. Same thing with the moles. One from the top, one from the bottom, leaving me with 2. And so now I will divide my numbers and my units that are left. I have liters squared, mole squared on the bottom, and minutes. And that's equal to K.